So when given an equation that encloses a radical and we need to solve for the x value. So remember, in order for us to obtain a solution, we need to isolate x. So one property that we need to recall is whenever you have the square root of a constant, the way we get rid of the square root is we take the power, the second power of it. The second power eliminates the square root and you're only left with the constant. The reason that is true because the square root of a is rewritten as a to the 1/2. So if we take a to the 1/2 to the power of 2, multiplying the power gives you a. So using this property, we will solve for x right here. So now here I have the square root 15 minus 2x. So the 15 minus 2x is underneath the radical. So my first step is, in order for me to get rid of the radical is equal to x, I need to take the second power, I need to take to the both side of the equation to the power of 2. So now this power of 2 gets rid of the radical and I am left with 15 minus 2x on the left-hand side of the equation equals x squared. Now again, I'm solving for x. Here I have a quadratic function due to the x squared right here. So the way I'm gonna solve this is I have to move everything to one side of the equation, setting the equation equal to 0, and then using the factoring method or the quadratic formula to solve for my x. So first thing I'm gonna do is I'm gonna move everything to one side. So I'm gonna subtract 15 and add 2x to both sides. 15 plus 2x. So now here I would have the 15 goes away, negative 2x plus 2x goes away, and now I'm left with x squared plus 2x minus 15 is equal to 0. So now right here, I can use the grouping method. So first thing, I need a times c right here. So my factor, my term a here is 1 times my c is negative 15. So I need two numbers that multiply to negative 15 and adds up to my b value, which b right here is equal to 2. So notice that two multiples of negative 15 are either negative 3 and 5 or 3 and negative 5. We also have 1 and negative 15 and negative 1 and 15. However, these two terms that when added together, there's no way we can obtain a 2. So these are eliminated from our list. So now here, negative 3 and 5. So if I were to add negative 3 plus 5, I would obtain a positive 2. So then my factor here is negative 3 and 5. Negative 3 and 5. And these would be my factors. So x minus 3 is one factor, and x plus 5 is the other factor, equals to 0. Now I need to use the 0 property in order for me to solve for my x values. So x minus 3 is equal to 0. X plus 5 is equal to 0. Solving for x gives me x is equal to 3. And x is equal to negative 5. Are my two solutions. However, especially since we're working with radicals, we need to check each solution we obtain because sometimes one of the solutions might not work. So now right here, I am gonna check my first solution. Check. X equals to 3. So now here I started with the square root. My function here is 15 minus 2x. Is equal to x. So now for every x I see, I'm gonna plug in a 3. So here I have the square root of 15 minus 2 times 3 equals to 3. So now I do the math underneath the radical. So 15 minus 6 gives you 9. Square root of 9 is 3 equal to 3, so that solution works. So now I have to do the same thing for x equals -5. So for every x value I have in my equation, I input a -5. Now, just by looking at this equation, the fact that I have this equation equal to -5, I know that this solution does not work because the radical right here, when I evaluate it, it's not going to give me a -5 number. So here I will just go on with the math to show you. So that's 15. -2 times -5 gives you +10. Equals to -5. Square root of 25 equals to -5. Square root of 25 is 5, which is not equal to -5. So that means the -5 is not a solution. So my only solution right here, the only solution to the equation is x equals 3. Now I'm given an equation where I have two radicals in my equation. So the first thing I'm going to do right here is move one of the radical to the other side of the equation. So here I have 2x plus 3 plus the square root of x minus 2 is equal to 4. So I am going to subtract the radical x minus 2 from both sides of the equation. So here I would have on the left-hand side of the equation, the radical of 2x plus 3 equal 4 minus the radical of x minus 2. Now here I am going to just concentrate on one of the radicals. I want to get rid of the radical on the left. So in order for me to get rid of the radical on the left, I am going to take the square of both sides of the equation. So by doing that, the square root on the left-hand side of the equation goes away and I'm left with 2x plus 3. And now here I am going to use the perfect square formula. So now here, to use the perfect square, I need to identify my a, which is 4, and my b, which is the radical of x minus 2. So now here the 2x plus 3 is what's left on the left-hand side of the equation. Using the perfect square formula, I'm going to have 4 squared minus 2 times 4 times the radical of x minus 2 plus the radical of x minus 2 squared. So now here, evaluating it, I'm going to get 2x plus 3 equals 16 minus 8, the radical of x minus 2, plus now this square gets rid of this radical. I'm left with x minus 2. Notice I put it in parentheses because I am going to distribute the plus. So now here I would have 2x plus 3 equal to 16 minus 8, the radical of x minus 2, plus x minus 2. Combining like terms gives me 2x plus 3. 16 minus 2 gives me 14, plus x minus 8, the radical of x minus 2. Now I got rid of the radical of one side of the equation. Now I need to get rid of the radical using the same technique. But first, what I'm going to do is I am going to isolate the radical to one side of the equation. So now here, what I'm going to do is I'm going to subtract 14 and I'm going to subtract x minus 14. So now here I would have x minus 11 equal to -8 square root of x minus 2. Now to get rid of the radical, I am going to square both sides of the equation. So squaring both sides of the equation would get me x squared. Again, I'm using the perfect square formula for this. So it's x squared minus 2 times 11 minus 2 times 11. And the a term right here is x. And then plus 11 squared. Now here, negative 8 squared is 64. X minus 2 is what's left here. So now I evaluate this. So x squared minus 22x plus 121 is equal, I'm going to distribute this 64x minus 128. So now I'm going to move everything to one side of the equation, again, because right here in this equation, my highest power is 2. So I would have to have a quadratic equation. So I would either have to use factoring, or I would have to use the quadratic formula, or even completing the square, any of these techniques to solve for my x. So here I am going to subtract 64x from and add 128 from both sides. So minus 64x plus 128. So here I would have x squared minus 86x and then plus 249 equal to 0. So now here I am gonna find two factors. Now I need two numbers that multiply to 249. So these factors are x minus 3 and x minus 83. So you can always expand this factors in order to make sure that these factors work. So now here, using the 0 property, I'm going to set each factor equal to 0 and solve for my x values. So x equals 3 is one of the factors, is one of the solutions, sorry. And x equals 83 is my other solution. However, in order for us to say that both of these solutions work, we need to check our answers by plugging in these x values into my equation. So let's check our solution. So let's start with x equals 3. Every x I see, I am going to input a 3. So the square root of 2 times 3 plus 3 plus the square root of 3 minus 2. We need to check if it's equal to 4. So now here I would have 2 times 3 is 6 plus 3 is 9. 3 minus 2 is 1. The square root of 9 is 3 plus 1 equal to 4. So now I have to check my other x value. X is equal to 83. So now again, I have this equation, and I'm going to plug in 83 for each solution I see. So here I have 2 times 83 plus 3 plus the square root of 83 minus 2 equals to 4. 169 plus the square root of 81. So the square root of 169 is 13 plus square root of 81 is 9. So 13 plus 9 is equal to 22. And 22 is not equal to 4. So that tells us that the only solution is x equals to 3.